Now let us solve this problem. If a uniform bar balances as on the diagram below with a 1.5 kg mass attached to one end here. So what is the weight? That is, what is the weight of this bar? Now, the first thing is that we are going to redraw our diagram to show all the forces that are acting on the bar. Now, here I'm just going to represent the bar with a straight line. So here I'm going to draw it like this. Now, the question says if a uniform bar, and the question is asking us to find the weight of the bar. Remember, the length of this bar, look at this diagram carefully, is 1 meter. That is 1.0 meter. Now, anytime a question says a uniform, we already said it before, that it means that the weight of that object is going to be exactly at the center of the object. So here now, the question is asking us to find the weight of the bar, and the question says a uniform bar. So the moment you see this uniform, you know that where you are going to put the weight of the bar is at the center. If you are given the weight, put it at the center. If you are asked to find the weight, also put it at the center. So let me extend this a little. So here, okay, let's say this is the center of the bar, and I'm going to put the weight here. I'm going to use W to represent the weight of the bar, and I'm going to put it at the center, meaning that this point like this, I know it is 0.5 to this end and 0.5 meter to this end also. So having done that, remember we also have this 1.5 kg mass. But now we are talking in terms of weight now. We are talking in terms of weight, and this is in terms of mass. So don't forget that weight is equals to mg, right? Which is mass times acceleration due to gravity. So this 1.5, I'll multiply it by 10 to change it to weight, right? So that's going to be 1.5 times 10. So that is going to be 15 what? 15 Newton. So I'm going to put this exactly where it is here. But now I'm going to put what? 15 Newton here. I'm going to put 15 Newton here. So here, look at where the pivot is 0.2 away from this end. So I'm going to put it where it is. So I'm going to put it here, and I'm going to my dimension, look at the way it is. So here, from here to 0.2 meter. So now can you see? Now remember that we put the weight exactly at the center of this bar. Why did we do that? We did that because they said the bar is uniform. Anytime you see that a bar is uniform, any object is uniform, that means the weight of that object or the mass of that object will be at the center of that object. And since this is 1 meter, so we put it at 0.5, which is the center here like this. So now don't forget that this is the center, and that is where we put the weight that we are being asked to find. So now let's put other things there. Let's show other forces. Now here we have the weight already. We have this. Now what about the distance from, let's look at the distance of this weight from this pivot, because I am going to be finding the moment. I'm going to be taking moment about this pivot. I'm going to be taking moment about this pivot. So I need a distance from this pivot to this weight. So, and that distance, I can put it here like this. Is since from here, from this edge to this middle, must be 0.5. Remember, that must be 0.5 because that is the center. So 0.5 meters, right? That must be 0.5. So it means that from here to here is 0.2, and from here to this is 0.5. Then from here to this place is going to be what? 0.3 what? Meters. 0.3 meters. Now, there's a force of acting downward here, which is 15 Newton. There is a weight acting downward here also, which is our weight that of the bar we are being asked to find. Now, because I am taking moments, I've said it in one of my videos that anytime you have a pivot here, then there is a reaction at that pivot. That whenever you have a pivot like this, then there's a reaction acting upward. But if you intend to take moment about the pivot, then you don't need to put the reaction there. You don't need to put it if you want to find moment about that pivot, because moment is the force times the distance, and since you are taking moment about that point, there is no distance. So that is why I'm not going to show the reaction here, any force that is acting at this pivot. And the force on the pivot, the reaction is always acting upward. Imagine something want to fall and then you're supporting it. So that means we are okay, right? So now we are taking moments about this now, and just know this force, this weight, if you are taking moments about it, that's this is the turning point. So this W is going to, which is the weight, is going to turn this bar, is going to turn it like this. Can you see? It's going to turn it like this, which is clockwise. And this, what is the moment? If you are taking the clockwise moment about here, then the clockwise moment is going to be 0.3, that is the force, which is the weight, W, multiplied by what is the distance from this point, that's 0.3, right? So that is the clockwise moment. Now this 15 is going to turn it this way, the other way around, like this, and that is anticlockwise moment. So that is the force 15 multiplied by the distance from here, which is 0.2, right? So according to the principle of moments, the clockwise moment, if a body is in equilibrium, remember this body is in equilibrium now because it is balanced. Now, according to the principle of moments, if a body is in equilibrium, then the clockwise moment, the sum of clockwise moments is equals to the sum of anticlockwise moments. So I can say that clockwise moment, which is W times 0.3, is equals to anticlockwise moment, which is 15 multiplied by 0.2. So here I'm going to divide both sides by 0.3. So divide both sides by 0.3, divide this also by 0.3. So this, we cancel this, and the weight is going to give us what? That is going to be, if you multiply both here by 10, so we are going to have 15 times, if you multiply this by 10, so that's 2, you also multiply the denominator by 10, that is over 3. So 3 here 1, 3 here what? 5, and 5 times 2 is going to give us 10. So that is the weight of the bar is going to be equals to 10 what? 10 Newton. Thank you.